Hi everybody, today we get to go ahead and start solving exponential and logarithmic equations. Now this is really fun, but there are a few different things you need to look for when solving exponential and logarithmic equations. So we will spend a couple days on this idea. Today we'll go ahead and look at the notes and you'll get a book assignment. On Monday, we will revisit section 7.5. I'll have a short video for you to look at just to review the basic ideas. So again, if this seems overwhelming, this is what we will be looking at both today, so Friday, as well as Monday. You don't have to get all of this in one day, okay? So again, we are solving exponential and logarithmic equations. Let's start off by, if you have an exponential equation, what is a way that you could go ahead and start this process? An exponential equation means that you have a base and your variable is an exponent. Step one, you always want to try to write them so that the bases are the same, because here's a really cool property. If I have the same bases, one base on this side, one base on this side, what you're allowed to do is cross off those bases and take the exponents equal to one another, and then you can solve. Okay, so this is the easiest thing if you can do it. Try writing so that way the bases match. If you have one base on each side and they're the same, you simply cross them off, take the exponents, set them equal to one another, and solve. Well, obviously you can't always make the same bases. It's not always possible. If you cannot make the same base, then you take the logarithm of both sides and use properties so you can solve from there. So let's go ahead and see what the heck this even means. So here's step one, and to save you on time, all I'm having you do is go ahead and solve them, okay? So I know some places say solve and check, some places say solve. We are apart. This is kind of a time-consuming thing. Just worry about figuring out how to solve them, okay? So this is 3 to the power of 2x, and this is 27. Step one, it says try to make it a common base. I can do that because 27, you guys, 27 is 3 to the power of 3. If I take 3 times 3 times 3, that's 27. So this is what step one means. Try to get a common base. Because now that this is a base of 3, this is a base of 3, boom, boom, you can cross them off. Then what you have left are your exponents. So 2x equals 3. If I am solving for x, I just have to divide by 2. So x equals 3 halves, or for those of you who like decimals, 1.5, and you're done. That's what that first property means. Try to get a common base. Okay, the next one. Again, I can get a common base because 9 is 3 squared. You still have your 8 minus x on the outside. 27 is 3 cubed. I still have that x minus 3. What I did though is I created the same base. They both have a base of 3. Remember properties of exponents. If you have exponents inside and outside, like we do here, you multiply them. When I'm multiplying, this is one term times two terms. So this 2 has to go to both. 2 times 8 is 16, minus 2 times x is 2x, equals, my base is a 3. Exponents inside, exponents outside, so you multiply them. One term times two terms. In order to do that, you have to distribute. 3 times x is 3x, minus 3 times 3 is 9. Okay, so what I did was step one on what they were telling us to do for exponential equations. I created a common base. Now that 3 can be canceled, you take the exponents, so 16 minus 2x, and 3x minus 9, and you set them equal to one another. Now you're just solving the equation. I cannot have x's on both sides of the equation. So if I add 2x to this side, I would have 16 equals 5x minus 9. Now if I add 9 over, we're just solving an equation. 16 plus 9 is 25 equals 5x. Now go ahead and divide by 5. 25 divided by 5 is 5, and you're done. So here are two examples of what they mean when they say try to get a common base. Super cool. Now again, that won't always work. That's why they have a step 2, okay? Or you take the log of each side. Now I can't make a common base here. 7 is a prime number, so I can't break that down any further. Don't make the mistake and say 7 to the power of 3. 7 times 3 is 21, not 7 to the power of 3. 7 to the power of 1 is 7. 7 to the power of 2 is 49. So it never hits 21. So what happens if you cannot make a common base, you take the log of each side. So the log of 7 to the power of negative x equals the log of 21. Properties of logs. If you have an exponent, it comes out front as a product. So negative x times the log of 7 equals the log of 21. So properties from 7.4. This is a product. I'm trying to solve for x. Product means you're multiplying. So I can divide the log of 7 to the other side. That way I have negative x. This you put in your calculator just like we did for the change of base formula. See, everything kind of goes together. They had you do the change of base formula so that way you'd be ready when you came time to solve exponential equations. Kind of cool. So log of 21 divided by log of 7. Okay, now here I'm rounding. So I'm going to round it to the 100th, but I need to realize that now it's approximately 1.56. Because I rounded, I can no longer say that it's equal. Equal means it has to be exact. This is approximate, just indicating that you rounded. X is not alone yet. I can divide by negative 1. So x is approximately, positive divided by a negative is a negative, 1.56, and you're done. Let's look at another one. Again, I cannot make a common base. 4, I could change into 2 squared, but I can't have 2 to the power of something and get a 5. So step 1, take the log of each side. So the log of 4 to the power of x minus 1 equals the log of 5. If you have an exponent on a log, even if it's more than one term, it comes out front as a product. So my exponent, which was a binomial, it's x minus 1, it comes out front. Now this is a product. If I want to solve for x, I need to move this log. This is multiplication. So to move the log, you have to do the inverse operation, which is divide. So divide both sides by the log base 4. This will, log of 4, doesn't have a base, it's an unwritten 10. This is x minus 1, that's what I have remaining. Let's put this in the calculator. So it's the log of 5 divided by the log of 4. Oh, again, I'm going to have to round here. So it's approximately 1.16. So approximately 1.16. Last step, if I want to solve for x, I need to add 1. So x is approximately 1.16 plus 1 is 2.16, and we're done. Super fun. Those of you who like to solve equations, today is your day, okay? We're going to do one more. Step 1, see if you can figure out a common base. Well, 2, this is good. I can't do anything with a 2. 15. 2 to the power of 1 is 2. 2 to the power of 2 is 4. Power 3 is 8. Power 4 is 16. There's no way to get it to a 15. So I cannot make a common base. So you take the log of each side. Log of 2 to the 3x equals log of 15. Anytime you have an exponent on a log, you bring it out front as a product. 3x times log of 2 equals log of 15. This is a product, so if I'm trying to solve for x, I need to divide log of 2 to the other side. So 3x, plug that in your calculator. Log of 15 divided by log of 2. I am rounding 3.91 if I'm going to the 100th. 3.91. Go ahead and divide by 3. X is approximately 3.91 divided by 3. X is approximately 1.3. Okay, now there will be scenarios where they have maybe an inequality instead of an equal sign. The process is the same, guys. You're just going to have a greater than symbol or a less than symbol within your solution. Okay, so here's an example. Suppose a bacteria culture doubles in size every hour. So that's why it's a base of 2, because you're doubling. How many hours will it take for the number of bacteria to exceed, meaning get larger than 1 million? 1 million is 10 to the power of 6. Okay, I can't make these have a common base. So I take the log of each side. So the log of 2 to the power of n is greater than the log of 10 to the power of 6. First thing I notice here, this is a log with an unwritten base of 10, so I can cross that off. This n has to come out front as a product because it's an exponent. N times log of 2 is greater than 6. To get n by itself, you just divide both sides by the log of 2. So n, which is the number of hours it takes, is 6 divided by the log of 2. So if I go ahead and I plug that in, it's approximately 19.93 hours. So it's the same process, but because they had the word exceed, that means that this needed to be greater than 10 to the power of 6. Okay, let's keep going. So those were our exponential equations. Now today we're doing exponential and logarithmic. So here is our process with logarithmic. Okay, if you can have the same base again, you get to cross off the log with the common base. So what that would look like, log base b, log base b. If there's one log on each side and they have the same base, you can just go, see you later, alligator, and take your x and your y equal to one another. Otherwise, when you're dealing with logs, you have to condense it down so you have one log and then cancel it by taking it to an exponential base of whatever the base of the log is. And that will make a lot of sense when we jump right in, okay? So again, you are just solving, okay? We're gonna go ahead and just solve the problems. This side has a log, this does not. Okay, so I can't do this property where I cancel. This only works if you have one log on each side and they have the same base. So what I need to do is cancel a log base 6. If I cancel a log base 6, I need to give it an exponential base of 6. What you do to one side, you always do to the other. 6 to the log base 6 cancels, so I have 2x minus 1 remaining equals 6 to the power of negative 1. Or you could write it as a fraction, 1 over 6, okay? I'm going to go ahead and use decimals. If I round it to the 100th, this is approximately, because I rounded, 0.17. Solve for x. So if I add 1 to each side, 2x is approximately 1.17. Divide both sides by 2. X is approximately 1.17 divided by 2 is 0.585, or if you rounded it, you could have said 0.59. Again, this was approximate because rather than saying 1 over 6, I could have here, because it's a negative exponent. If you wanted to use fractions for this problem, you could have. Otherwise, I just rounded it and said this is an approximate answer. Okay, let's keep going. Ooh, I have 2 logs, but they're not on opposite sides. So what I need to do is condense. Step 1, I see an exponent. There's a 3 out front. That 3 means that it was really an exponent on x. So if I'm condensing, what I need to do is get this in a format where I can bring them together. Okay, so the 3 would have to go back. This is a log base 10. This is a log base 10. Adding goes with multiplying. So this is 3 equals log base 10. 8 times x cubed is 8x cubed. So I condensed it because when you are solving logarithmic equations, you only want one log on each side. I had 2 here, so I had to use the properties to condense it down to 1. There was a 3 here. If you have a 3 up front, it means it was an exponent. So in this case, this 3 was an exponent on x. Now, this is log base 10. To cancel a log base 10, you need to give it an exponential base of 10. Now 10 to the log base 10 cancels. This side is 8x cubed. 10 to the power of 3 is 1,000. Now you guys were just solving. So if I take 1,000 and I divide it by 8, 1,000 divided by 8, you get 125 equals x to the power of 3. In order to cancel a power of 3, you take a cubic root because a cubic root cancels a power of 3. Now remember the way to enter this in your calculator. If it's more than a square root, if we want a cubic root, you put the index. So in this case, it's a 3. You want to hit second caret symbol. because that way you get this symbol where there's a little x. This 3 replaces the x. So it's a cubic root of 125, so your answer is 5. Done. Okay, let's look at the next one. Hey guys, again, they gave you logs, more than one on one side, so you have to condense them. When you're doing logarithmic equations, you want one log per side only. So I can rewrite this as 1 log base 4 because this is a log base 4, this is a log base 4. Subtraction goes with division. So this is 100 divided by x plus 1. Now that I only have one log, it's time to cancel it. To cancel a log with a base of 4, I have to give it an exponential base of 4. 4 to the log base 4 cancels. So this side is 100 over x plus 1. 4 to the power of 1 is 4. Now what I need to do is cancel the denominator. I can multiply both sides by x plus 1 because that way I no longer have to deal with a fraction. This is one term being multiplied by 2. So again, you'd have to make sure that you are distributing. That 4 goes to both terms. 4 times x is 4x. 4 times 1 is 4. To solve for x, minus 4 to each side. 100 minus 4 is 96. Divide both sides by 4. 96 divided by 4 is 24, and you're done. I hope you guys are enjoying this. I love solving equations. So to me, this is one of the most fun sections. Okay, let's look at page 6. Again, I have logs on both sides. You have to condense them. In order to condense them, you have to send any exponents back. So this was log of x squared minus log of 4 equals 0. Okay, so we're kind of working backwards. We have to condense it back. This is a log base 10. This is a log base 10. Remember, if they don't have a number written there, they have that unwritten base. Because they are both logs with the common base, I can write them as 1. Subtraction goes with division, so it's x squared over 4 equals 0. Log base 10 needs to be canceled. To cancel a log with a base of 10, you give it an exponential base of 10. 10 to the log base 10 cancels. X squared over 4 is what I'd have left on this side. 10 to the power of 0. Anything to the power of 0 is 1. Now if I want to if I want to solve x for x, I have to isolate x squared. So I need to cancel the fraction by multiplying both sides by the denominator. This side would have x squared remain. 1 times 4 is 4. Last step. If I want to cancel this power of 2, you take the square root of each side. Anytime you cancel a power of 2, you have to include both the positive and negative. The square root of 4 is 2. Done. Okay, let's look at the next one. Now this time, you are not condensing. Okay, I do not have 2 logs that I'm trying to condense. Because there's only one log, bring that exponent out front. So it's 4 times log base 5 of x equals 8. I'm not condensing, so I bring the exponent out front. This is a product. I need to divide that 4 to the other side. So log base 5 of x equals 8 divided by 4 is 2. Last step. If I want to cancel a log base 5, I need to give it an exponential base of 5. What you do to one side, you always do to the other. 5 to the log base 5 cancels, so x equals 5 squared is 25. Done. Guys, we're almost done. Holy smokes, last page, sad. Okay, this side of the equation has 2 logs, but they both have a common base, so I can combine them. So log base 12, adding goes with multiplying. So I'm taking x times x plus 1. So I'm multiplying the 2 values that were with the log. I'm multiplying one term by 2 terms. So I have to make sure I distribute. So log of 12, log base 12 is x squared plus x equals 1. Now that I only have one log, it's time to cancel it. To cancel a log with a base of 12, you need to give it an exponential base of 12. 12 to the log base 12 cancels. This side is x squared plus x. This side, 12 to the power of 1 is 12. I have a power of 2. In chapter 6, we talked about the fundamental theorem of algebra. That means that whatever the exponent is, that's how many solutions you need to find. We need to find 2 solutions here, you guys. So I'm going to go ahead and take this 12 and minus it over. So x squared plus x minus 12 equals 0. Now I can factor it. 2 numbers that multiply to negative 12 but add to 1. Well, that's going to be positive 4 and negative 3, because positive 4 times negative 3 is negative 12. 4 minus 3 is 1. To find your solutions, you take each factor separately and set it equal to 0. So x plus 4 equals 0, x minus 3 equals 0. Now you solve for x. So if I minus 4, x would equal a negative 4. If I add a 3, x would equal a 3. Last one. Just because we went ahead and did some logarithmic ones, I wanted to end with an exponential function, okay? Remember exponential functions, see if you can make a common base, and here I can. So 2 to the power of x is greater than 4 can be written as 2 squared. The reason why you would want to do that is because then I can make a common base. Properties of exponents. You multiply inside exponent by outside exponent. 1 term by 2 terms you distribute, so this is 2x minus 2. Common base. I have 1 base on each side. They are both a 2, so I can cross them off. So I have x is greater than 2x minus 2. If I minus 2x from each side, 1x minus 2x is negative x. That's greater than negative 2. Divide both sides by negative 1. When you divide an inequality by a negative, you flip the sign, so x is less than 2. That is 7.5. So your assignment, you're going to go ahead and try 1 to 17, and then go ahead and jump ahead, try 19, and then 21 to 36. If you are struggling, there is a Zoom call on Monday in order to ask questions. So you do have today and then all weekend to kind of work on this assignment. Monday, there will be a really short video to review how this works, and then there is a Zoom call where you have the opportunity to ask questions and do any of these with me that you find challenging. I hope you guys have an awesome weekend. I miss you so much. Talk to you soon. Bye.